Hello, my name is Janelle Crocker and I teach at L.W. Higgins High School in Jefferson Parish. As an educator, I am most passionate about empowering students to see mathematics as a tool for understanding the world around them. I strive to create a classroom environment where students build confidence through problem solving, collaboration, and meaningful connections between math and real-life experiences. In this video, you will see my 9th grade intensified Algebra 1 class. Students identify the function family represented by tables, graph the data, and connect features of the graph with function families. Also, students surface and diagnose misconceptions related to finding rate of change by working with examples and analyzing the data from the online assessment. The content being taught is aligned to the Louisiana State Standards and the Algebra Mind Intensified Algebra 1 curriculum. The objective of this lesson is for students to identify relationships as linear or nonlinear from tables, graphs, and descriptions. By the end of the lesson, students should be able to identify from tables whether a relationship is linear, exponential, quadratic, or inverse variation. Prior to this lesson, students explored rate of change in various situations by examining the multiple representations of graphs, tables, and functions. Students were introduced to situations where the rate of change was constant. To prepare, I analyzed student exit tickets from previous lessons to identify misconceptions and adjusted my small group plans to provide additional support where needed. This lesson connects to my broader instructional goal of developing students' mathematical reasoning, communication skills, and determination when faced with challenging problems. In this class, I teach a diverse group of learners, including students with IEPs, 504 plans, and English language learners. To ensure success for all of my students, I have incorporated visual supports, scaffold examples, peer collaborations, and sentence stems for mathematical discourse. Finally, I would like the selection panel to know that my classroom is built on foundation of respect, encouragement, and growth. I believe that every student has the ability to succeed in mathematics when provided with the right tools, support, and opportunities to explore their thinking. Thank you. All right, so for today, bell ringer, you should have been working on page 384 in your Algebra Mind student workbook. Homework tonight is on page 383. You do have a test tomorrow. That is a major grade, topic 9, end of assessment. Okay, so let's go ahead and get started with today. Go ahead and go to page, what is it, Lakaya? Page what?
379.
379. Okay, does everybody see 379?
Yes, ma'am.
Okay, so if you see it, give me a head nod. Cool. All right, so the opener. It says, consider each table and decide whether it could represent a linear function. So let's break that down. What do I mean by linear? Yes? It has a straight line. Anything else?
It's going the same rate.
It's going the same constant rate. Good job. What do he mean by constant rate?
It stays the same.
It stays the same. Good. Now, when we talk about a function, how do I know it's a function? Yes?
If it has like one input and one output, or if it has one input and multiple outputs.
Correct. Do y'all agree?
Yeah.
I agree. What's an example that I usually give about function? Yes.
The TV remote, if you turn it on, it either goes, if you press the red button, it either go on or
Good. And then what's the other example with the remote? What you got, Percy?
If you press channel 1, it's going to channel 1.
Correct. Do we agree?
Yeah.
All right. So consider each table, decide whether it could represent a linear function. At this time, go ahead and answer questions 1 and 2. So I'm gonna give you time to work by yourself, and then I will allow you to work with your partner. If you understand, give me a head nod, please. All right, let's roll. Okay, mind you, we are only doing the opener. Only the opener. Okay, now you may go ahead and discuss with your neighbor. Go ahead and discuss with your neighbor about which one you think is linear and why, please. I hear math conversations, I hear math vocabulary, keep it up.
This would see on the coordinate plane, it would go in a straight rhythm, like it would go in a vertical line.
And this one makes sense.
Wait, no, vertical is this one, right?
Vertical is straight, vertical is straight.
Yeah, so
But it would be a
go,
positive slope.
yeah, positive slope.
Okay, do we need the full 2 minutes?
Yes,
Who
ma'am.
needs the full 2 minutes? Let me see. Okay, I'll give you the full 2 minutes.
And then after that, you keep putting because it's decreasing by 14, so it still be.
You got that?
That's the really big.
Alright, perfect. So, consider each table and decide whether it can represent a linear function. Okay, out of these, which one do you think is a function, and tell me why? Keith?
I think the second one is function
Okay, you think number 2 is a function? Why do you think that one is a function?
because it's all positive, like, you know how number one got a negative?
Okay, you see how this side got negative? Uh-huh.
On that axis, so-
Okay.
So on the second one, it don't have negative, on the x over y, so I put that as a function.
Okay.
All equal to.
I could take that. You said that because this one had negative numbers, but this one has positive numbers. I'll take that. You want to add to that?
Yeah, like Percy said, the operation is addition, but it has a constant rate of 4.
I agree. The operation is +4, and it doesn't have a constant rate, which that constant rate is +4.
But that's what makes it a linear equation.
Agreed. Anybody else want to add to that? Okay. Yes.
And it's going a straight line because it's going about 4.
So if I were to chart this, right, on a coordinate plane, it will make a what? Now, remember yesterday, we thought that one of them was going to be linear, right?
Yeah.
Until at the end, what happened? It had a little slight curve because what happened towards the end?
It stopped
When
going,
we looked at the
it stopped
table,
going the same rate.
it stopped going the same rate. To review today's lesson, you will focus on the following highlighted goals from this topic. Identify relationships as linear or nonlinear from tables, graphs, or descriptions. Identify from tables whether a relationship is linear, exponential, quadratic, or inverse variation. So let's break that down. Linear and nonlinear. What makes something linear and nonlinear? Talk to yourself first. 5, 4, 3, 2, 1. Go ahead and discuss with your neighbor. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So what makes it linear, Brandon? Or linear and non-linear?
Linear is like when it goes in like the same and constant rate.
Good.
And non-linear is if it's not going the same constant rate, it's going like decrease or have negatives.
Good. Anybody else want to add to that? Logan?
Non-linear because it don't have a constant rate and plus it's not a it don't have a pattern.
Good. You want to add to that?
Like he said, if it's a constant rate and non-linear, but like for example with the skating with the motion detector,
Mm-hmm.
if he was going like at a constant rate and then he went up or down and then he went back, so that's what makes it non-linear.
So Jacora, he's reviewing, you remember how we talked about the skateboarding and the petit,
Motion.
oh, I'm having a brain fart. Depending on how your speed is will determine whether it's a constant rate. Good. Now, I was hoping that I heard somebody say the 2 vocabularies that we learned yesterday that also means non-linear and linear. That starts with the letter P. Proportional and what? Non-proportional. So which one is proportional?
Linear.
Linear. And then which one is non-proportional? Non-linear. Good. With those functions, you told me that it's dealing with the X, or the input and output, right? Tell me about, what's another word for input?
Multiplication.
Input.
Independent.
Independent variable, domain, and then of course it just called it what? X, right? Give me something for Y. Range, dependent variable, and output. Good.
Oh, wow.
Alright, cool beans. Let's go ahead and get started with our core activity. As you have observed through analyzing rates of change, you can sometimes find patterns that reveal which type of nonlinear function, such as a graph, may represent. Now, you can use what you have learned about rates of change to decide what type of function would best model a particular data set. So at this time, I want you to answer questions 1, 2, 3, 4, and 5. You may go ahead and discuss with your neighbor which of the tables are linear and non-linear. Make sure that I'm hearing you tell them why.
I'm taking she is together. Or divide by 2 for each one, so it's boring.
All right. Class. Okay, so let's look. The first one, is this linear or non-linear? Non-linear. Okay, why?
As you see,
If you look at what?
because it's like the same one as we did from earlier.
Right. If you look at the y-axis, it's not what?
It
That's
hasn't
what's the
changed.
main word you need to say? Starts with a C.
Constant.
And the constant
Rate.
of
Change.
change. Good. Okay, what about this one? Linear or non-linear? Linear, because it does have a what?
Constant rate of change.
Right, and it's going.
About 4.
What was the rule?
Operation of 4.
Operation of 4. What kind of operation? Addition. Okay.
Linear.
Then here,
Linear.
linear as well. What's that one going by?
Multiply by 2.
Multiply by 2. What about this one?
Non-linear.
Why?
Because it's going down.
It's going downward,
It's called y'all constant rate.
but it's decreasing not at a what?
Constant rate.
Constant rate. This one, at this time, what I would like you to do, I want you to log into your computer and start on your topic 9, lesson 6, more practice. The objective of this lesson was for students to identify relationships as linear or nonlinear from tables, graph, and descriptions. Overall, I believe the objective was met. I was able to confirm this through student work samples, class discussions, exit tickets, which showed that most students were able to identify from tables whether a relationship was linear, exponential, quadratic, or inverse variation. During group activities, I also observed students articulating the reasoning and correcting one another's errors, which identified a deeper conceptual understanding. If I were to teach this lesson again, I would provide additional time for students to compare and contrast the different relationships. Although students were successful with the procedural step, some still relied on, pattern recognition rather than understanding when one method might be more efficient than the other. Allowing time for structured reflection and discussion would help strengthen their decision-making flexibility as problem solvers. Following this teaching segment, students will apply these same skills to real-world scenarios, such as word problems involving mixtures, motion, and even budgeting. This next step allows them to connect abstract reasoning to practical context and demonstrate mastery in a performance-based task.